So our second session this morning, the objective, as we have said, is to see how we can roll out recycling on an industrial scale. So we have to look at where we stand also in the area of footwear, especially soles. We're going to talk about innovations, automatic tools to process material. We'll look at breakthroughs and things like that. We will cover these points until lunchtime. To start, I would like to welcome Louis Beauquesne, in charge of industrialization at Refashion. And he's going to tell us about the state of the art in the area of recycling in France and Europe. Now, good morning. You know, I come from l'Aisne, a district in France, or a département in France, where you have very nice villages. But before, you know, we had Continental, we had large groups in that region. And now there's no longer any industry. And when we talk about recycling, we have to think about industrialization, we have to talk about sovereignty, but we also have to talk about all these regions in France and in Europe where there's a real need for reindustrialization. So let's look at the state of the art concerning recycling solutions in Europe. We'll look at some figures concerning France to start with, then we look at the value chain. So when we talk about recycling, what do we actually talk about? And then we'll try and look at the future volumes to recycle in 2030 in Europe. So some main figures, 59,000 tons. That's the CHF volume collected in France by operators, approved operators, and that were recycled for construction, that is to say for insulation, for things like that. There's also a lot of cutting for, you know, wiping cloth, and less volume is for yarn and closed loop. Now, 25% of the recycling was done in France, 31% in Europe. So that's good. We can do better, but it shows that we have the expertise. But there's still 44% of that source that was recycled outside Europe. So this is a loss of value for France, for Europe, and a loss of sovereignty. So this is the recycling of the textile. So let's look at enhanced recycling. Today we have units in Europe that work well, and we have a lot of pilots in France that will become industrial in the years to come. So we are very confident that in France we have the ability to process all our waste in the short term, 2027, 2028. But there are still some bottlenecks in some area. For recycling preparation, we prepare the material for recycling. Then we go to recycling, where we have mechanical recycling to produce yarn as a closed loop or other operations. And there we can process a lot of the waste. We have to go further. But then we have the chemical recycling. So we looked at our source in 2023, and we saw that 11% of what was collected and that was to be recycled was made up of PET. So we have these chemical recycling units. They're still at the pilot scale today, but soon they will become industrial, so we will have a capacity to cover all our source. Of course, it would be good to have incentives, and there's still a business model to be found. And then when we talk about recycling, we have to talk about reincorporation. Today we have insulation. It works at an industrial level. We have capacity. We also have the fiber product, but there are other outlets in the area of reincorporation, like the plastic processing. So there also we need a business model and make sure we avoid bottlenecks. McKinsey did a study in 2022 where they looked at the future, and we see that according to their calculation, in 2030, we will have 7,200 tons to be recycled. So they put dots on this map. So 7,200 kilotons to recycle, a huge amount. And in 2022, for the whole of Europe, we recycled 500 kilotons. So 10 times more in 2030. So this is a great opportunity, but we'll have to create capacity and we'll have to win markets. But keeping in mind, the figure will need, in fact, real engineering, European engineering skills. Thank you. A short question. We talk about chemical recycling. It was mentioned in some sectors today. It seems to be the big solution. We get to the monomer to produce virgin material. What about the textile? Is it really the solution or still complicated today? It is a promising technique. You know, we have a lot of polyester, 11% in 2023. And so there is a source for that. There's also polyester in blends. We have a lot of studies, and we see that in the area of textile production, the share of polyester will increase with time. So in our source, we'll probably find more and more. So the chemical processing is important for us and for the whole recycling sector. Another point, when we look at your map, you talked about French sovereignty and French engineering, but there are a lot of dots outside France. Well, this is a McKinsey study. I think there's a random distribution of the dots, taking into account projects that exist and future projects. But yes, we have fewer dots in France, but I'm sure that in 2030, when we do the map again, maybe France will be covered with dots. So Refashion is focusing on that, well, you know, we have an eco-organization, in fact, dealing with the French source, but we also work with some foreign operators. Thank you. Thank you very much for your presentation. Now, moving on to footwear. Footwear is the new development, maybe. So to look at the recycling state of the art, we'll listen to Cécile Martin, responsible for research and development at Innovation. We will also have Alex Marcoing from CEITIA, Mathieu Vicard, project manager working at the Technical Center concerning footwear, as well as Guillaume Messin, who is working for IPC. So, thank you all. Thank you, Cécile. Thank you, gentlemen. So, the state of the art in the recycling of footwear. So, Cécile, now, can we talk really about recycling footwear today? Concerning recycling of footwear, with Louis, we saw that textile recycling is ahead of footwear recycling. So we have to speed up in this area. So we will start with the recycling of soles. And there we have recycling technologies that are slightly ahead of the recycling of the other parts of the shoes. Now, soles represent 50% of the average weight of a shoe. Especially today, we have very thick soles. It's the fashion today. So we thought we should start focusing here on recycling of shoes. Shoes are a very complex product, more complex, in fact, than clothing. And we don't always know the material used. Difficult to identify. Mathieu, you talked, in fact, in footwear. You are in the technical center working on leather and shoes. Can you tell us a bit more about these shoes? Well, let's say that the shoe is made up of two main parts, the upper part and the sole. And already it's a complexity because the material is very different in the two parts. And this is why we have two pathways, in a way, either for the shredding of the whole shoe or the other approach is dismantling, separating the upper part and the sole. So you see here the makeup of a shoe. Same thing for all shoes. You will have some elements that will be more or less present. And each part of the shoe is very specific and means a specific use for this or that part. So we have different materials, we have thermoplastics, we have textile, elastomers, metal parts, as we see with the shanks. So this is not something you find in all shoes, but still in many shoes. So we have to manage that source, overall source, that represents a certain number of problems because there's a great diversity of elements. In an upper part, you can have 15, 20 different materials that are fundamentally different. We're not talking about cotton with some share of elastane. No, we have very different components. So in the upper, 20 materials, the sole, well, there are fewer materials, but still. So this is why we focus more on the sole, because of the weight and diversity of materials that is smaller. But here we have two examples of soles. You have the white sole that seems to be a single material, but it seems to be only. The second sole is made up of different materials, a different type of material. So in that's a complexity. And once again, the sole represents 50% of the weight. So from an economic point of view, priority management, this is where we start focusing. Because for the upper part, it's closer to textile. And, it means that for the upper part, it will go to maybe landfills or solid recovered fuel. Well, we do our best. And today we don't really focus on the upper, even though some people have managed to do single material upper parts. But we start focusing on the sole, and most players focus on the sole today. So in your center, you worked on characterizing the different parts. Well, in the technical center concerning shoes, we tried to support the industrials, the marketers, to facilitate the design of the recyclable products, but we also support with recycling operators. We work with a refashion to try and better characterize the source, better understand the source, and really understand where are the real barriers. So The first thing is to sort as much as we can for the source. Yes, and we'll see this with my colleagues. Sorting the incoming product is important, and also the knowledge of the product is important. We have a few examples here. It's not an exhaustive list, but what we see is that the large families, and here we're only talking about the soles, and there we have big categories: thermoplastics, thermosets. There are people in the room who are highly specialized, so don't hesitate to talk with them. But already in these categories, we see the processing won't be the same. And on the diagram, we talked about a density approach for the sorting. This is one of the solutions we have today to try and separate the different materials. But with the red circle we have here, we see that for the same density, we can have materials that are completely different within the large family of elastomers. So the whole issue is the following. If we do not know what's incoming, and if we do not know the makeup of the source, even sorting visually or in a more or less automatic manner, the difficulty is that the identification of the material is going to have an impact on the recycling method we can propose. But already there are barriers here. So there's the sorting issue. There's also knowing the source and transferring the information so that at the level of recycling, we can do something smart and relevant. Thank you. Thank you. And Alex Marcoing, R&D at CETIA, an innovation platform devoted to recycling for textile and leather products. So you looked at the mechanical part, and this is already a difficult part. At CETIA, we started study some time ago on separating the upper part and the sole. This is the picture you can see on the right-hand side with the robot. So these are developments we have made to try and have pure soles so that we can better recycle the material. But there are other solutions that exist and have for some years, because, for example, SOEX, that is no longer SOEX today, was the first industrial solution for recycling, dismantling, preparing shoes. They started in 2012. In 2018, they commissioned the first dismantling center for the shoes. So they used a shredding solution. So shredding, aerolic separation, and separation of the different materials to obtain all the sole material on one side, textile and textile fluff, and other players use that same process. For the separation between the upper part and the sole, we do pulling. We also use another process to get the highest level of purity. So there are different solutions, like the IDELAM process. I know that IDELAM is in the room today, so you can also meet with them. It's like a pressure cooker. You increase the temperature, the pressure, you have a reactor, and you inject a fluid, and it will dissolve the glue and separate the different materials in the shoe. So there are processes that are more industrial today than others may be, but you also have those under development. And in both cases, there is this notion that sorting is important. Whether you talk about dismantling the upper and the sole, because depending on the process you use, we cannot put the same shoes in all processes. And to get interesting purity and to be able to have a good recycling, you have to be able to sort upstream, and this will make it possible to improve the purity of the product at the other end. So the more flows that come in, the more process lines you need. Well, there's the shredding that makes it possible to cover all. But then depending on the technologies, yes, there are specificities for different types of shoes, and especially the assembly of the shoe. Now, Guillaume Messin, you're a commercial manager at CTC, and before I said the technical center concerning leather. Is it leather or is it footwear? Both. There's one C, which stands for chaussures and cuir, so leather and footwear. In fact, we cover the whole leather sector, starting with tanning companies, but also all the footwear. Okay, so Guillaume, you are working in the area of plastic processes. Now, when we deal with footwear, we have different materials. Some have the same density, so it's a real issue. How do we go about this? Well, we constantly try to adapt, find the best technical solution. At the level of IPC, we have quite a big expertise in the area of recycling, but maybe more in the area of plastic. For soles, it's a different challenge. We see this on the diagram. We can have different type of processes, more or less complex, depending on the complexity of the material, with a systematic steps to reduce the size, like shredding. Then we can have micronization. We can have thermomechanical processes. In micronization, we have a micronizing unit, then extrusion, compounding to produce pellets, and other processes like cross-linking, devulcanization. And there we try to recreate material. There are different sequences that are more or less difficult, more or less costly. And of course, there's also the economic dimension that we need to keep in mind. So when we shred all these soles, you have what? Powders or pellets, which are made up of different polymers. Yes, especially if we have not done the sorting correctly. But in the area of recycling, the big thing is to sort upstream to get a source quality that is as clean as possible. That's the big challenge. And the more we focus on the upstream, the easier it will be to recycle. We'll be able to remove pollution, barriers, to avoid having a certain number of elements. So different samples. Maybe you want to tell us more about these samples. Now, we started with the soles like this one. And in this first approach at IPC, we have done a certain number of steps, shredding, extrusion, filtration, and we get this strand, a plastic strand, and then we obtain plastic pellets. And then we have re-injected plates incorporating different quantities of recycled product. So this is to see the characteristics of the material and their evolution, the more we inject recycled product. So if we put 15, 30, 50, 60% of recycled product, will we get specifications that are still satisfactory, or is there a threshold or limit to the incorporation of recycled product? This is the idea behind the studies. Yes, because if the final product loses in mechanical, from the point of view of mechanical resistance, it's a problem. Yes. Now, I'm coming back to the chemical process, why don't we focus on a chemical approach? Because we have a number of components that is maybe limited. We could come back to the monomers. Well, it's a very good question. There's a lot of discussion concerning chemical processing. I think that one of the industrial sectors where they're advanced from the technical point of view on the packaging side, of course, there we have pushed a mechanical approach is better for the environment. But because of the quantity of source, the volume, we will need a chemical approach in addition. But concerning chemical recycling, we can't say we're going to take just about any product and use a chemical process. No, there's a separation process, there's an upstream preparation that is necessary. And finally, there's a large part of mechanical recycling that has to be integrated also, even if you aim for a chemical approach. So here we see shredding, extrusion, but it goes further than that. Yes, we did 2 other tests, one on micronization of rubber soles. So there we get a powder after the micronization that we have injected different volumes of them in plates to actually characterize the mechanical characteristics of these new plates. So different plates, different levels of incorporation, 5, 10, 30%. Let me say that we also have done some tests concerning the whole sole. We also tested devulcanization with 8 impact. So we tested different percentages, done an assessment, and characterized the new injected plates. So concerning the sorting, we have to do more sorting. Maybe, Mathieu, you want to insist on this point. Yes, what we see, or what the recyclers get is this, and that's in the best case. That is to say that the sole is already separated from the upper part. So we see that just for this, one of the first things Cécile mentioned among the barriers is carbon black. And there we see here a black part, so there's probably black carbon, but also other barriers and different compositions. And that is very difficult to get. What is the actual composition? So the key here, as Guillaume said, depending on the recycling route you choose, and you choose it on the basis of the process, but more specifically on the basis of the material that comes in, the feedstuff. The shredding will take place for all products, but whether you choose micronization or devulcanization, you need to master the product coming in. And from one rubber to another, unfortunately, you don't have the same quality. And when we see the devulcanization test behind me, it can be very relevant if you can characterize the source in a very fine way, and then you get good mechanical properties because the material is close to a virgin material. But if we do not control the feedstuff that arrives, the source, then it'll be difficult to get something relevant and to get an interesting reincorporation rate. So material identification is important. So you need that upstream sorting. And once we discover these elements, then we can reincorporate in an easier way those materials in a matrix. And we can even produce soles, as we have seen. So do we know exactly what is done today? Do we have figures on what is done today in the area of recycling? No, we don't have figures on this yet, but there are many, many projects, many initiatives, and we are going to identify this in the years to come and better characterize the material thanks to sorting to, in fact, make progress in the area of recycling. So here we present the recycling solutions that we have identified in our studies. Yes, something like 20 recycling solutions. It's a non-exhaustive list. We're still finalizing the list. So there's still new companies that will come up. We have technical centers, transformers, recyclers, incorporators, companies who do both. And then they have more processors and machine manufacturers. That's also interesting. So we have done a bibliography. We've organized interviews with the different players to get the specifications concerning their process, what they were able to do, what materials they can process, what were the minimum quantities or volumes to work at the level of research and development or production. Also, the quality criteria concerning the incoming source and what they could actually produce at the other end. Okay, Cécile. We do not have the preparators or preparation units that, in fact, so we have not included everyone. Now, maybe we have forgotten a solution. If you are aware of this, don't hesitate in telling us. We'll be able to add this to our state-of-the-art study. And of course, the state-of-the-art will be updated as solutions come up on the market. And to conclude, this is something we have done to look at recycling solutions for soles and a closed loop to come back to a shoe at the other end. There are other solutions where we can use an open loop. All the players we have met with within the framework of that study all require a preliminary test before they do an industrial experiment. This is important because we still need to stabilize the process on sources of used shoes. And sometimes there's a cleaning or washing phase to remove stones, chewing gum, and what Mathieu has mentioned. This has to do with the material sorting. If we want to get a quality recycled material, we have to do an enhanced material sorting. So we have to find the right level of sorting to make sure we get a quality product at the output of the recycling process. And maybe the marketer people can do something at the level of the eco-design. Maybe they could move to using a single material. That would really help. Well, yes, this is what we said before, to make recycling easier. But we have to process the shoes, that exist and that we have in our cupboards. So we started studying the recycling of soles, and the next step is to look at what is done in the area of the recycling of the upper part of the shoes. A broad topic. And how long has this topic of footwear been around? We have the impression it's quite a new topic. We are no longer in the research and development phase, but how long have we been working on this? I think we should, turn to the industrialists who looked at the topic. It is quite new because there were no real solutions until now. And, we say that the textile source is made up of a great diversity, but for footwear, it's even more. You have different shoes, from a baby size to a size I don't know what, for, size 50. So great, such a great diversity. So we decided, to start looking into that, but step by step. Okay. Thank you very much for this focus on footwear. Thank you very much.
I'd like to thank these gentlemen. I'm going to keep Cécile with me, and she's going to be joined by Léa and Jean-François Crispert, who is from Valvan. They sell automated sorting machines, and we'll keep Cécile with us. You can welcome them. It's always nice to be welcomed on stage. We've spoken a great deal about sorting, and we have recalled how important it is to have upstream a qualified material source, and that today it's almost a dream to have this. And today this is going to be possible thanks to the library, the materials library. So the materials libraries are a new tool. We can speak of the new textiles and shoe and footwear materials. But in 2021, we spoke of a new textile materials library. These are the samples, textile samples, most found in household linen. And this is what we find in sorting centers at the end of life. So we have a library of reference samples to be used to certify the material composition. And so today you have the suppliers of technology for material recognition, which has been further developed. So here, what do you mean? We have to have reliable labels, or they're not reliable? Now, we'll talk about the labels after, because we have some very good examples resulting from our lab tests. At the sorting centers, very often you have no labels, or labels that have faded, and so you have a good 50% of the source material that cannot be identified. So we have created these libraries of textile material samples. We have once we did that, we decided to have a library of these textile material samples, and we also want to have a library of footwear sample materials, so as to have a library for references for the sorting of footwear. So here you have a broad definition of the principle of the materials identification technologies. It works for textiles, but also footwear. So you have, in fact, a scanner here, which is going to scan the material and emit a spectra, which is going to then be compared thanks to algorithms. It's going to compare this to other spectra already in the system, and in this way we can identify the material in question of the textile or footwear at hand. So as far as the systems database is concerned, we needed to have reference samples for which we were 100% sure of the makeup. of the sample, so as to ensure there wouldn't be any mistakes made after. Now, as far as this new library of textile materials is concerned, we have 28 categories of material composition. It is the 24 categories that we had in the old existing library, to which we've added 4 new categories, and this following the characterization done in 2023 on textiles sources. So you have 7 pure materials like cotton, polyester, polyamide, acrylic, wool, and elastane, because elastane has to be identified as well and detected. Then you have blends of all of these different fibers in textiles. So we had to acquire these samples mainly from French industrialists, but we also obtained sources in the retail sector and in inventories. So we took all of these into the laboratory, some 150 samples. We were thus able to consolidate both the library and the information in a database. Here you see the definitive library for textile materials. So here you see the number of samples per material category, 25 maximum samples per category, right down to elastane, for which we have 7 samples. We have produced 10 identical copies of the textile library, and all in all, we have 464 samples per copy. Why 464? Well, that was not the actual figure targeted initially, but following tests done in the laboratory, we tested all of these samples according to the ISO 1833 standard, which is the standard used to certify the makeup of a fabric in terms of materials. And I must say we had some samples which were not good at all, those in yellow on the graph. Usually these are blends with wool or acrylic. We have better conformity with pure materials, which you see indicated at the top of the list. If we go deeper into the results of the analyses carried out in the laboratory, here are the types of nonconformity we identified when testing the samples in the lab. There are several reasons for this. First of all, the error in terms of the proportion of a material according to the standard. You cannot have more than 3%. And here in the results, we saw a 10-15% in the lab results, but you might have an additional material identified or a material less, one material replacing another. And then you can have materials which are replaced or added. The bottom of the graph, you see the rate of conformity for each type of sample sourced. And happily, the rate of conformity of the samples for the industrial sector, you see 68%. For the retail stock, a little under 50% of conformity in the lab tests. This is very much in line with what we had seen in our first textile library. We had better results with the industrial samples, but overall we're more or less dealing with the same figures. So what are the lessons to be drawn here? Quite simple. It's impossible to trust the labels on clothing to carry out a reliable material sorting. It's also difficult to find a textile sample which is certain in terms of its composition. So now I can give the floor to Jean-François. Yes, so you are in fact a manufacturer of sorting machines. You've tested the library? And why is it important to have used this samples library? This is because of the degree of accuracy of the identification. You have infrared technology, which is good. You get all of the information, and then you have to process it. So for that, we need the library. If you have a low quality library, you're going to have a low detection level. So this is the reason that we need the library. We started in 2011 with a fiber source. At the beginning, we would read the washing instructions on the label, and that was extraordinary, what the information there. So, in fact, with the infrared technology, we found we were still missing something, and that was the library. And with the library, I must say, even with that, it was a real effort. We started with samples of clothing manufacturers, fiber manufacturers. Then we looked at other things, and luckily we discovered refashion. So today, we continue to use this for our system. So you enter the data in your machine, so then the products can be oriented as necessary. Well, this is a kind of benchmarking we do. We've got to do it very quickly. We have to compare these signatures. And this obviously is going to depend on the accuracy of the samples. And for that, we use the refashion database. So today, all of your machines are equipped with the library? Yes. So this means that here we're talking of the first library that you used, and we were saying that in the end, the nonconformity rate has not evolved greatly. Now, in the automated sorting equipment, is it important to keep this library up to date? It's an open question. Anyone can answer. Yeah, Leah? This is the first textile materials library. And at that time, we had a nonconformity of 41%. Now we have a conformity rate of 47%. As such, it's not important to update the library, but we had a lot of requests from sorting operators, manufacturers of sorting machines as well, who wanted us to serve them. So what does the library look like for people in this room to understand what we're talking about? Well, here we are. So we continue with clothing. We have a suitcase. This was the best packaging we could find for the library. So here you see the interior of the library. Here you have materials samples, some knit samples. You have some balls of yarn and even some elastane samples. We have 10 identical copies available for the next developers of automated fabric recognition machines. Well, that was interesting. That was deserves to be looked at. So here, this is a textile library, but, as we said earlier, we're speaking of footwear more and more, and Refashion has looked at this as well. Yes. given the experience we had with the two initial textile libraries, and to support the work on the footwear, we've also worked on the library for footwear materials. The methodology is the same as for the textile library, so we wanted to identify the different categories of materials that we would include. And we looked at the materials that are found in the soles and heels of the shoe. These are the largest parts of the shoe, but also the simplest. Then we wanted to also have a supply of samples for those who supply the market, the sole manufacturers, suppliers to shoe repair shops. Then there's the verification of compositions in the laboratory. Contrary to textiles, here you have no standards to certify the composition of materials used in footwear. As Mathieu was saying earlier, we have different categories of materials, so we looked at two different laboratory methods, one for the hard thermoplastics and one for the thermosetting materials, and one for elastomers. And so then we have a consolidation of all of the information in a database. So in the shoe material libraries of samples, you have 7 mono materials, single materials, and 4 blends. And here we're not speaking of any additive that's added, but we saw that when we have information on these additions, we can add it to the library. So here you see also the question of colors, origins, etc., given for each category of material. So the library, 10 identical examples, 122 samples per copy of the library. So as with the textile sample library, we have a classification and a declassification system when the sample does not have the material indicated. Here you see the same thing, the interior of the suitcase. Here it's beige in this case. So 10 copies, which are proposed to the sorting operators and manufacturers of materials. So here, in fact, the goal is to identify the materials. And what's important with this library is that it's more complex to access the sole composition. Here on shoes, you have pictograms indicating whether you have man-made materials, leather, textiles, etc. That's about all you have on a shoe to identify the materials. And as was said this morning, identification and sorting are the keys for developing the recycling of shoes and textiles. Thank you very much. It's a perfect conclusion there. Thank you very much. It's your business to know this. So thank you for informing us on these 2 suitcases, which allow us to access this information. Thank you. If you'll have a seat. As you probably know, the summit is also an opportunity to highlight and reward developers of projects. You know, we have an innovation and industrial challenge for developing the sector. So there are calls for projects for recycling and accelerating the industrialization and circularity of this sector. 2 challenges and innovation to take into account the challenges here. So the industrial one is the improvement in the recycling of CHF on an industrial basis. So we have the winners of the challenge. So once again, with Cécile, Yes, of course, with your applause. And Louis, that we saw earlier, Louis Boken, the objective is to reward the men and women who day after day work to recycle, to develop the recycling of CHFs. So, I'm going to ask the winners to come up as I invite them. So, Geneviève Podgers, forgive me if I massacre your name. Podgates. I'm from Vosges TLC for the recycling of fibers in the Vosges, optimized optical sorting of textiles. Emmanuel Kiskeski from the company Recyloc Textiles. Here we have a oversorting for recycling purposes. In fact, here we are talking of guanidine. Yes, I'm sorry, says the speaker, I have to read this. Then we have Pareto. This is for new fibers and textiles. This is the development of a demonstrator and an industrialist for this automated sorting of textiles by color and composition, and this so as to prepare their recycling. That is, say, we're speaking of garnetting. And here, Olivier Simil from Ecotex Lou et Simon. Here, in fact, the objective is to ensure the functioning and industrial deployment of a unit for automated sorting by spectral recognition, and this in a closed loop. So then we have, in fact, Delange Recycling. They're not here, but here, in fact, it's a line of optimized optic sorting and cutting. And this for the non-woven market sector. He's not here, but a winner. Here, this is the industrial challenge now. We have the company Dagobert, Romain Maillot, for the installation of a complete line of garnetting for the production of non-wovens for the insulation market. Then we have, in fact, Plastri, represented by Clara Spectropot, for identification of black and multi-layers. This is the development of a new method allowing the identification of the material composition of CHFs that have already been used and not reusable. Then we have Refresh Global for the open and closed loop project. This aims at using a biotechnological process for the separation of patented fibers by Refresh Global for simulating consideration of recycling non-reusable textile waste post-consumption. Idelam with Thomas, who was here earlier, for Rechose Tout. And following this study of delamination of used non-reusable shoes for the recyclability of delaminated materials. Congratulations. Sandrine André from Canoë for the Calico project, who is not here today, but we can applaud them as well. So this project is recycling and valorization of high added value of used acrylic textiles into fibers. The Velotex POS project for Movi. The thermomechanical recycling of different sources of waste textiles that are not reusable in polyester, the characterization of the materials, and their possible reuse in other purposes. Then we have Synthetica Synthetica, Marco is with us, yes, for the TITES project, the recycling of used pantyhose that are not reusable to produce a 100% recycled nylon fiber for new pantyhose by Dean Brands International. So there we have all of the winners, and I propose we take a picture with these winners. If you can all come close together so we can get a group picture. The photographer is going to tell me whether I need to move out of the picture. Yes. The small people in front, the short ones in front, the tall in the back.
Et bien voilà.
So there again, congratulations to all of our winners, and some of you, I think, will be doing pitches this afternoon. So during this afternoon sessions, you will be able to say more about the work you've done here with these projects. Thank you. Now, while stomachs start growling in hunger, we are coming to the end of the morning's work, and I'd like to invite Véronique Allaire, the head of Paul Perma Refashion, and Maud Hardy, to come and conclude this morning's work. Remember, there will be more this afternoon. So I would like to thank all of those who have participated in this morning's summit. I think we've seen a lot of the players already. We've been able to see to what extent Refashion enables us to remove barriers to recycling. We saw this with the way we accompany eco-design on disruptors and enablers to recycling. We saw it in the experimentation that is carried out to enhance the complete sorting chain right up to the preparation of materials. And we hope that soon we will announce the availability of these recycled materials right up to the incorporation of this recycled material so as to truly industrialize the value chain. We've seen the production of studies. You've seen just a sample of these studies this morning. You saw the materials library. The textile materials library is quite modest, but you need to note that this library of textile materials represents 2 years of work at Refashion, and it has really enabled all of the automated sorting solutions to take off and be efficient. And I hope that the footwear materials library will enable us to really take off here as well, so as to make the sorting of these footwear materials easier and less costly. We saw that with all of the winners of the Refashion Challenge, we have more and more developments to enable us to be more efficient, more effective, and to be and reach closer to the moon. And we really need to accelerate this activity so that we keep these materials, these sources, and this technology in France and in Europe. Maud? Thank you. So I get to say the closing words. I've done nothing, but I get to close the summit. Well, fine. First of all, I obviously want to thank Véronique and all of the PERMA team, all of the COM team, all of the speakers who are so passionate and enthusiastic. And I'd like to once again thank and congratulate the winners. We really worked and enjoyed selecting the winners. So congratulations. As you know, Refashion is working, acting, financing, and accompanying you in all of these developments, which we will enable us to collect, sort, and recycle. Since 2023, we've accelerated the accompaniment on these priority subjects because our new accreditation for 23-28 is going to give us the possibility of financing financing industrial projects. For the moment, we were financing R&D projects, but we can accompany you in financing these experimentations as well. And very soon, we are going to have the possibility of financing concretely solutions which will enable us to reduce the price difference between the end of the process where the recycled material comes out and its incorporation and its new use as a material. So I think that what's really important is the level of knowledge. So this afternoon, during lunch and the afternoon, you're going to be able to meet, discuss, exchange, and network to jointly develop the future solutions for tomorrow. And this so as to say that France is sovereign in its industrial capacity to recycle its waste. So I count on all of you and our great team to create this sovereignty. And so take advantage of this afternoon. Take advantage. And your challenge today is to speak to 10 people you don't know. Don't come and talk to me, you know me. But go and talk to 10 different people here. Attend the various pitches, propose projects, even projects you might think that you think are minimal. But the moon, this morning we spoke of the moon. The moon is accessible. Talk about your projects at Refashion with Sophie, Antoine, Cécile, all of the members of the teams who are here to help you create these marriages between different people here. So remember, we are today's recycle man and recycle woman so as to build tomorrow. So congratulations to all of you. And remember, now it's your turn to work. Thank you.